the shop. Every year in North America, 75,000 people per year hurt themselves on this machine. 10% of those are amputations. So every year in Canada and the US, 7,500 people will cut their fingers and hands off on this piece of equipment. And I say that because taking this seriously and having a respect of this piece of equipment will go a long way. So it is a specialized piece of equipment. It's called saw stop. Has anybody ever been exposed to that? Does anybody know about that? One, two, three. So if you, after this is over, if you go onto YouTube and type in saw stop, you'll see this piece of machinery in action. It's a very specialized piece of equipment. Basically, what I'm going to do is anytime my hand is inside that red zone, that red piece of plastic is called the throat plate. So anytime my hand is 4 inches or closer to the blade, I need to do something about it because that's illegal. So one way I can do that is turn the power off, that's here, and turn the power off here. You'll have to take my word for it that it's off, but if you get on your hands and knees, right where my pen is pointing, there's a hole that goes through the red plastic, and inside the hole it says off. When you rotate it 90 degrees, it says on. So now it's off, and sure enough, when I go to turn it on, it won't activate. So now the saw is dead. Now I can touch the saw because I'm safe to do it. There's double redundancy on the kill switch because if I'm turning the saw off and I go to touch it, or worse yet, I'm underneath and working on it, and one of you walk by and bump that, it'll turn on. I have my hand off, so I don't want to do that. So I'll have a double redundancy to do that. So we'll expect you to do that. If you want to pinch in for a minute, this is a table saw, and it operates just like any table saw you've ever seen, except it's a very specialized one. So right here where my pen is touching, you can see a piece of silver aluminum. That piece of silver aluminum is a computer that is the same as this model. Here's the piece of shiny aluminum that I'm touching right here. That's the same thing. You can see it's a 15-pin computer. So what it does is it's the exact same technology as those novelty lamps in any hotel you've ever been in. You touch any part of the metal and it gets brighter. You keep touching it and it finally turns off. Everybody with me on that? So what happens is this computer sends out an electric current through the blade and back to the computer. If nothing happens and that current is the same going out as it is coming in, it just operates normally. As soon as my flesh touches this blade, it makes the computer realize something's different, and in this case, it deploys that spring and slams that cam into the teeth of the blade, and the blade impregnates itself into that blade like that, and stops the blade from spinning in 1/1000th of a second, and drops everything below deck level. So if this is properly working, it reduces that injury rate of 75,000 per year to less than 1%. So it's a really important piece of equipment. We're never going to rely on that, but we're glad that it's here and we want to use that. So any questions so far? That is one that actually got set off by one of the students. There was a piece of metal in the wood, and the computer picked up that current and deployed the spring to set it off. So everybody was safe. We just didn't clean the lumber appropriately. To give you an idea of the pressure, if you hold that up for just a second, those two circles, those two holes were perfect circles when it started, and it got mashed. So it's a three-quarter horsepower engine driving that at 6,000 RPMs. So a ton of power that completely destroyed that cam of aluminum by design.
Before it's deployed, it's sitting.
Yeah, exactly. Yes, you just have to take my word for it. Yeah. It's fit perfectly out and they mesh in together. So that's the kind of force. Okay, everybody good with that so far? Okay. So, I think I'll defer to your instructor, but I think if there's a blade change or some major maintenance issues, we would take over at that point. So
Yeah.
I'll just go over the high altitude.
The high altitude stuff,
Okay.
yeah.
So what we want to see on this blade, minimum, are the throat plate. That's that red piece, and it's painted red as a warning sign to make sure that if I'm in the red zone, there's a problem, so I need to stop. My hand should never be in there. Okay, and I also have this silver shark fin. That's called a riving blade, R-I-V-I-N-G. And what happens is when I cut a piece of wood, if you could pretend for a minute that this is one solid piece of wood, and as I'm passing it through and cutting it, well, depending on how wood was grown, it will either spread apart as it gets cut or pinch in. If it pinches in, that's very dangerous, because what happens is it's pinching in on the back side of that blade, and that's the blade that's kicking towards you. So as this is pinching in, it's wanting to put it back into your face, like that. So what happens is we have the riving blade, where as it's pinching on that silver, not on the blade. So as it goes back past there, we don't carry it. So it's a safety issue. We can override and take that out, but we don't want to do that because we absolutely need that. Is everybody with me on that? Typically, what we're going to do is have the safety gate as well. So I don't expect you to know how to alter this. I'll do it for you. You will have this in place when you're using it. So this is a very fancy riving blade. So you can see there's that chrome riving blade of the same design, but just a lot more going on. So I'll have that in place. I'll have my throat plate in place. The purpose of the throat plate is there's a lot going on in here. And when I go to cut my wood, I want to interface with that blade, but I don't want to get hung up down in the guts of that. You can see how messy that would get and how quickly that would get. So in theory, this gap here is 0. So when I put it on, I can't wedge my stick down inside the guts of that and get myself in trouble. It's gonna run parallel with the tabletop, and that's what I want. Okay, so I have my riving blade that's preventing my pinch off the back side of my blade. Then I have a finger guard, so you can see it's got guards everywhere. I'd have to manually try to interface my fingers with it if I do that. It rides up so that as I put a piece of wood through, it pushes up on the fence, but still keeps me safe where I don't want it. And as the wood goes through, the fingers lift up and I can cut like that. So the fence is very important. Then I have these kickback fingers right here. So you can see there's a very sharp sawtooth on there. Again, this blade is spinning that way and your body's there. So anytime there's a pinch or a bind or something gets hung up, it's got to release the pressure, and the way it does that is pushing the board through your body. So most shops I've ever worked in have a wall of shame, and the wall of shame is directly behind the saw, and there's things as big as a 2x4 fed into the wall. This piece could literally go through you if you don't do it right. So I just want to be honest with you and tell you why you're getting such intense safety training. So back to the kickback fingers. Again, the pressure and the direction of that blade are that way, right where your body is. So the kickback fingers work, so I'm feeding into the blade, underneath the guard, underneath the fingers of the guard, and now I'm interfacing my kickback fingers. The kickback fingers have those sharp, they're spring-loaded, and they have those sharp teeth, so that when they interface, I'm pulling on as hard as I can, and it's locking it. It's preventing it from kicking into you. That's there for your safety. I say that because when I adjust it, I can put them up out of my way. But if you're operating it with them up out of your way, they're not useful at all. So you need to manually lower them down and put them through. Everybody with me so far? Okay. All this right here, there's a lot going on, and I cannot pass my wood through. If I'm cutting a big chunky piece of wood and I go through my blade, I can't go past that knuckle because it's too hot. So how high is that knuckle? I don't know. I didn't measure it. I don't want to get close to the blade to measure it. So there's a real easy mechanism to allow you to bypass that. When I have my guard in place, then I bring down what's called the bump guard. That's not in place. There's two little ears here. That's in place. Once that's in place, the height of that knuckle is the same as the height of that knuckle. So if I can clear this face, I know I can clear back through there. If I'm bumping here, I might as well stop and readjust because I'm not going to clear there. Does that make sense? Okay. So the final piece of this is dust collection. Dust is as big a health hazard as anything else here. So when the air is on, it'll automatically siphon up through my guard. So all the void inside that clear plastic will suck the dust up and come out of here. There's also suction underneath, so wherever that dust goes, it's going to go away. Again, the blade's spinning this way and it's going to kick all that dust into your face and you're going to breathe it, and that is a health hazard. So some of it is even carcinogenic, depending on if it's cedar or pressure treated, so you want to be careful with that. If your saw is in that configuration, I have very little concern about you everything's operating full. Okay? Good. So I'll just take you on a quick little field trip and I'll show you where and how to turn on the dust, and then we'll come back here and pretend like the dust collector's on. We won't keep it on right now because it's noisy and you'll want to have the video to watch, so we'll not put it on, we'll pretend as if it is. So
I know, eh?
What is this? I like down here for the rest of the year. You guys are never fun.
okay, this is the dust collector panel, and it's really easy. System start, system stop. This will be your job to turn it on and off as you're making cuts. Anytime you make a cut, in real life, you're going to first come here, you're going to make sure everything's in position, you're going to ask permission, all your safety gear's on, and then you'll just push start. You'll see it'll take a minute to get up to speed. In real life, as I press start, by the time I get physically over to the saw again, it'll be up to speed, but you'll hear it gear up. So now it's fully up to speed. Now it's doing its job over there. You cut your wood, whatever you want to do, and then you turn it off. That's it. Okay? But that'll be your job to activate it and deactivate.
I don't know what's going on. You probably got the
I gotta cut strips to. Did I mess up what you're doing?
Yeah, I just need 10 more minutes.
Okay.
Yeah, and I'll call you when I'm over.
Jurassic Park where he has the Velociraptor.
That's it.
Oh god,
I call it a shark.
I gotta wait.
So if you get to the saw and it's not looking like this, just come grab Trevor and I immediately. There's a lot of reasons why a professional doesn't want all that or has to alter it, but we'll not get you in those positions. We want you to be safe. So you may see it without this stuff, but just grab us and we'll put it in place. Okay, so I'll get my dust collector back on. And now we're ready to go. The way the saw operates is this is called the fence. So the white part is the fence, and it locks here and it unlocks here. I can have the fence on this side of the blade, and I will always have it on this side of the blade. I don't think you'll need an opportunity for it to be on the other side, but we can talk about that if it arises. I have graduations here for when the fence is on this side, and I have graduations here for when it's on this side. There are two bubbles. I will read the bubble on the right when the fence is on the right. So right is correct, and you want to be on the right, reading right. So right, right, right. That's how you can remember that. You will screw yourself up. Right now I'm at 6.5 inches. Right now that says 6.5 inches, but I'm way more than that. But you will miscut that if you try that. You have one other option, is you can bring all your safety gear up and measure from this face of the blade over to the fence. And I'll make it 3 inches. So there's 3 inches, and there's 3 inches. So it's easier to just use that. So I am unlocked, so when I want it to be precisely 3 inches and then I lean on it, it's going to float away. So I want to set it to 3 inches and then lock it. Now I'm okay, now I can lean on that. And that's a precision piece of machinery. This is the most important thing that's going to prevent you from getting hurt. Just go for a coffee for 10 minutes. Okay, I know I'm throwing a lot at you, but these are all important things. Is everybody okay, or do you want to talk about something I missed? Everybody good so far? Okay. The way this operates, and I'm not going to have you alter it or check it, but this face of the fence is exactly parallel with the face of the blade. They're running exactly parallel. The second one of them's cocked one way or the other, you're in a major amount of trouble. Again, I'm cutting this, and I want it to run smoothly through. As soon as one of them's canted one way or the other, you're making a wedge. That wedge is making a bunch of pressure, and the pressure can only go one way, and that's through you. I've had a board kick back to me, a piece of plywood 12 inches by 12 inches, and I had a bruise on my groin bigger than a basketball. And as hard as you could swing a piece of plywood, like a baseball bat, it hit me that hard, and I fell to the ground on my knees, and I thought I'm going to have to call the phone for 911. It's that much pressure. And none of you are strong enough to prevent that from happening. So you have to use your brains, not your brains. Okay, so having said that, when I want to cut something, my body is always right here. I'm always right in front of the blade and right in front of the fence where I can see it. So my body's here. I just need to talk to you guys is the only way I have. When I'm cutting something, 100% of the time my eyes are only right here on that gap. I only care about that thing in the world for that moment. I don't care who's doing what. As soon as I see a gap like that, or a gap like that, there's a massive problem, and my eyes are the thing that's going to tell me there's a massive problem. And when I say a gap like that, I really mean a gap like that. That's enough to kick it back. My eyes are making sure that this is running parallel. My hands will never leave this piece of wood until the wood is passed out past that throat plate. So the same thing. If I freak out and let go, all the pressure that's keeping that board there is gone, and now the board's going to go through you. So I'm never going to take my eyes off that gap. This is the only thing in the world I care about, and my hands are never going to let go of that wood. Okay, you all with me on that? So those are absolutely critical. That's make or break to help you or hurt you. When I'm running this, I'm going to act as if the air is on. So I'm going to go turn the air on, make sure everything's in place, make sure everything's in place on my body, ask permission, then I'm going to turn it on. If you want to come on over here. So it's off right now. It's on the redundant switch. Now I'm going to turn it on, and you'll see it's a computer, like I said, so it's going to calibrate. Red, green, red, green. As soon as it's green solid, I'm good to go. Now it's green solid, so it's ready to go. It's not on because I haven't turned it on yet. This is the paddle that turns it on. And that's the paddle that kills it. It's a paddle for a reason. When I'm operating this, I never take my eyes off, I never take my hands off. Well, what if there's a problem? If I'm feeding my lumber through and there's a problem, the last thing I need to do is take my hands off and go look for the switch. Because I've done both things wrong. I've taken my eyes off and I've taken my hands off. So when I go to run this, I'm going to put my thigh right in front of that massive kill switch. And I'm going to have my hands and my eyes where they need to be. My eyes are here, my hands are here, and I'm feeding through. I see a problem, I'm going to kill it. I'm not taking my hands off and I'm not taking my eyes off until that blade dies. Now I can do it. Most of the guys that get hurt in this shop find a problem, kill the blade, and then let go because the blade's dead. That blade takes 30 seconds to stop. While it's taking time to stop, it's going to kick the board through you. So, eyes and hands on all the time. Everybody good with that? Okay. So, I'll grab some lumber and we can make a couple practice cuts. I have right here, there's a bin here and a bin here, and they're full of push sticks. So there's a couple different styles. This one is preferable and the best, but it totally depends on what you're doing and your personal comfort and all that. What I do is, as I'm feeding the wood through, I will use my hands and I'll make sure that that gap is perfect. As I feed it through, once I get to here, I'm starting to approach that 4-inch mark. So I can't let go. I still need to have hands on. So what I'll do is grab this or this, and I'll use it and I'll grab it. There's a little heel here, and I'll grab the heel on, and then I'll push it through. Everybody with me? Or there's a little heel there. I can grab it and push it through. Okay, everybody with me? I don't know, I'm throwing a million things at you. The only thing I care about is that there's zero gap, that it's really, really tight over here, right? So if I'm over here pushing on it, I'm pulling it through. See how I can't control that very well and it's hard to keep it straight? I don't care about anything on this side of the blade. The only thing I'm going to touch and care about is on that side of the blade. So I could be cutting an 8-foot sheet of plywood. If I'm cutting 3 inches off that 8 sheet of plywood, I could care less about that 8 feet. I'm only worried about this 3-inch piece. So only ever are your eyes and hands on this side. Whatever's over here, I don't care. If it's a big cumbersome piece and you need a partner to help you support it as it goes through, that's fine. But all the pressure's over here. The person on this side is just a dummy, just holding it up and floating it along. The second this person here pushes it like that, you've got a wedge and it's going to go back and hit you in the face. Everybody with me? Okay. So what I'll do first is maybe a wide 6-inch cut. And I will set my fence on the right side at 6 inches. I'll lock it down and then I'll grab my piece of plywood and I'll feed it through. When I feed it through, I want to keep my eyes on this gap and my hands will never let go. If I see that there's a problem, I've got my thigh next to the kill switch. Okay, everybody good? I'm also going to preemptively put these in a position. If they're over here, I've got to let go with my eyes and my hands and go get them. So I always keep one, this narrow one, right in that trough, and the other one leaning right there, and you're good to go. They're always right there next to your person. Any questions? Okay, so I'm going to activate the saw. I'm going to get my body in position. My eyes are only looking at this gap. Now you can see there's a problem, and that's perfect. Well, my body, my eyes and my hands are the only thing that's going to do that. The world is going to make that become a wedge. You are the master of this thing while it's running, and you're the only thing that's going to make that run properly. So you're going to do all your eyes and hand work to make sure that happens. When I do that, 90% of my weight is going that way. I'm pushing 90% of my pressure that way and 10% that way. I'm really worried about that gap. I don't want there to be a wedge there. So I'm pushing hard. I'm pushing that hard to make that piece of plywood. And I'm not kidding, I'm showing you, because a lot of people do it wrong. I'm pushing that hard on the fence. Okay? Hard. So I'm going to move my body to operate it properly. I'm just showing you. Perfect. And I'm looking here when I'm saying that. Perfect. Problem. Problem. Everybody with me? So I'm in the position. 90% of my pressure is going that way. 10% that way. Now I'm in that 4-inch zone. I'm going to grab the paddle. Now I'm clear and I can feel the power.
Josh, just a couple more things before I'll end the video.
Yeah.
One is to show the yellow things, the holders.
Yeah. Okay.
And another is the number of teeth that should be shown.
Sure. Okay. So that's a good point. So we have a feather board. So I'm going to kill the power again. The first thing we can show is the number of teeth. So everything I'm cutting is a different thickness, and so I want to have the appropriate amount of teeth sticking up. What I need to do ultimately is cut this piece of wood in half. So I need the teeth to be sticking up through it. If I have my teeth sticking up through it that high, I have that much teeth to cut my arm off. So I don't want to do that. I don't want to get myself in harm's way like this and not have enough teeth so it's not doing anything, but I don't want to put myself in harm's way. The general rule of thumb is when you're cutting something, you want 4 teeth to be sticking up above the piece of wood. So right now I have 1, 2, 3. Everybody see that? So I want to be a little bit higher than that. I'll release this gear, right, the center gear, and you can see I'm raising it up and I'm lowering it down. I'm going to lower it down until I'm at 4 teeth, which is right about there, and then I'm going to lock it down. With that rule of thumb, you could see I cut the tips of my fingers off, but I couldn't cut my hand off. And more importantly, I'm safe that I'm not partially cutting this wood, I'm completely cutting it. So 4 teeth exposed is the general rule of thumb. Okay? If I use a piece of plywood, and it depends on the plywood, this is 1/4 inch, you can see my blade is way too high. I could cut my whole hand off. So now I'm going to lower it down to 4 teeth. And again, I cut the flesh of my fingers, but I probably wouldn't cut them off. And that's why we do it. So every board, what you're cutting would be a custom cut. Everybody with me? Okay. The last thing that I'll show you is a feather board. So say you're going to do a piece of trim work around your box and it's very small, maybe half the size of this. Well, you're really inside that 2-inch, that 4-inch mark where your hands are in harm's way. If I was going to cut this in half, my fence would be here, and I'm feeding this in here, and it's getting a little dicey, and I'm worried about safety. So one thing we can do to prevent any injuries is we have these 2 things called feather boards. The simpler one I'll show you first. It's a feather board because just like on a bow and arrow, it's got those feathers that feed like that. These have magnets so that when you put it down, and there's indications that have arrows pointing that way and it says on. So right now it just slides around. If I turn the magnets on and activate it, it becomes a very strong magnet and holds itself there. What I do is I'll set these next to the fence, so I'll lock my fence down. And say I want to cut 1 inch off this piece. I'll line my board up, set my feather board, and you can see how I'm compressing the feathers a little bit. I'm putting pressure on it. That's just barely touching. That's compressing, you can see that. Then I'll activate my magnets, and now it's locked in. The reason for that is I can feed it through that way with the feathers, and it's pretty heavily locked going the other way. So remember, 90% of my pressure I want to push that way. That's already happening because those feathers are pushing it that way. And it's keeping it razor straight right there, which is what I'm most worried about. So it's doing a lot of the thinking for you. Everybody with me on that? So that, and you can cut 14 of those in half every minute and I'd be happy as long as you don't hurt yourself. So that's in harm's way, not you. So that's the most important. The other one is exactly the same thing, just a little more complicated or a little more useful, depending on how you look at it. So here's the same thing. There's my feathers that compress this way, and now I have feathers that compress down. So not only am I pushing it this way, I'm pushing it that way, and I'm that much safer. It's not going to flop around and vibrate. So I'm using a feather board that way. We good with that?
Yeah. One last thing, Josh,
Yeah.
is just how to set an angle on the blade.
Okay. So, say I want to use this as a piece of trim, and I want to cut a 45 and cut off that shaded mark like that. So I'm making a picture frame, and I want to wrap the corners of this window 45, so they're kissing together, and I want to cut that. So what I'll do is I'll raise my blade. So again, I'm loosening that center nut, and I'm raising it right up. And then I'm coming over to the side, and there's another wheel here. I'm loosening that center nut. And then you can see graduated on the front face, 0 degrees up to 45. And as I rotate it, I can't see it from my angle, but you can see it going 5, 10, 15, 20, whatever it is.
Yep.
So whatever your graduation is, typically what you're working on is either going to be 0 or 45. So you'll do that. When you bring it back to upright, there's a stop. I'll bottom out here in a minute. I can just feel it. So I just bottomed out. I'm just barely hand tightening that. If I reef on it, I'll break the guts of the saw. So I don't want to be rough with it. It's a precision machine. I'll just back it down a little bit and then tighten that off. You got to lock this in place. The saw vibrates quite a bit, and if you don't lock everything down, it'll vibrate out of position. So if you want it perfectly 0 or perfectly 45 and don't lock it, I guarantee by the time you're done with the cut, you'll be 5 degrees off and it'll just be wasted piece. Okay, everybody good with that? Is that good?
Perfect. Thank you, Josh.
Good.